to all the streams out there. Okay, I think ties up. So thank you everyone for joining, and welcome to today's webinar. Hopefully you will learn something from this. And of course, depending on where you're watching, there should be ways to ask us questions throughout the webinar. So please do ask questions as obviously we cover the topics, and then at the end of the session, we'll then have a question and answer where we'll cover those. So please do comment away, and then we'll get to those at the end. So I'll start off by introducing myself. My name is Alex from Trotec Laser. We're an Austrian-based manufacturer of laser systems for both flatbed and galvos. And today we're going to hopefully be showing you a collaboration with some robotics. So I'll pass across to Henry, who will just give a little introduction of himself.
Thanks, Alex. Yeah, as I said, my name's Henry. I'm one of the directors of Inovo. We're a UK-based robotics company, and we've just recently developed a new product, which is a modular cobot arm, which is suited to help automate tasks quickly and easily. So we're going to talk to you about that today.
Great. So let's dive straight in, and to start with, we'll just cover some of the basics quickly for anyone who isn't aware of exactly what a laser is. So a laser is a type of light, and that light has a very intense heat, and it allows us to process a lot of different materials. So it allows us to, typically the two applications we think of are cutting and engraving. And the difference, I guess, to some of the more traditional methods of material processing is the fact that it's a non-contact process, so it really adds a new dimension in terms of obviously the reliability and also the speed for lots of different applications as well. So I'll now pass back across to Henry, who will give us a bit of information about exactly what their products are, and especially what a cobot is, as that's something that I had no idea about to start with.
Yeah, so our product is a cobot, and the big difference between a cobot and a more traditional industrial robot, which is generally what most of us have sort of seen on TV in car plants and those sort of environments, is a cobot is something that's much more flexible, much easier to use. It can operate around people without heavy duty cages and a lot of additional safety equipment. Cobots tend to be lighter duty. They lift sort of in the region of sort of 3 to 5 kilos. They don't move massively fast, but they're very good at doing the kind of tasks that we do manually. So they won't pick up whole cars, but they're very good at loading machines or doing simple assembly or palletizing and those kind of things. So our robot is unique in that it's modular. So what's different about ours is that these sections between the different joints can be quickly replaced, and that actually allows you to change the physical reach, and that adds another layer of flexibility that you don't get with other cobots.
Okay. And of course, today, what we're looking at is the combination of these technologies. So I guess one of the questions hopefully you have if you're watching is, why are you considering this? And generally it's because with processing of materials, we have a lot of customers out there that are very creative. They're producing unique and one-off bespoke products, but also, there's a big need and a demand for actually processing of, the same item or the same type of item over and over again. And of course, those tasks of loading and unloading in particularly can be obviously quite monotonous. And so what we're hopefully going to show you is that obviously the combination of this can be a great way to kind of relieve some of your workforce to actually be able to do other tasks in the business itself. So the first application we have is a component marking application. And generally what we find is for something like this, we're looking at a machine like a speed marker. So this is a galvo type laser. That's a laser where the actual laser head is stationary, and it uses a mirror to very quickly move the laser head and the beam, or move the beam across the part and have very quick marking. So again, it's something where you'll be loading, unloading quite repetitively, quite quickly as well, and so it's obviously a good application for this kind of technology. So obviously, I guess a big question you will have is how easy is it to set up? So I'm going to pass across back to Henry, who will hopefully give us a bit of information about the process we went through to set up.
Absolutely, it's a pleasure. So, I mean, we set out to make our robot as user-friendly and easy to set up as possible, and our target market was very much this kind of application where the actual task you want to do is going to change from time to time, that it's more batch production. And so what we've done is we've built a system where you can program the robot by moving it between real points in the real world, and you store those positions, and you basically build up a list. So you don't have to program this in the context of a traditional programming language. In this system, you're basically teaching it where you're picking things up, where you're putting things down, where you've got to open and close the gripper, and then essentially just telling it what's the pattern. So you've got to repeat this many times, or if you're unloading things from a grid, you say these are the corner points and there's 6 rows and 3 columns, and then it will work its way through those. So it can do the repetitive part for you. So in these examples, we linked the robot to the machine, so we could basically send a signal to tell it to open a door with the Galvo. With the Speedy 400, we actually used the robot to lift the door mechanically because that didn't have an electric actuator. So a lot of flexibility to how you solve these problems in different ways. But in all 3 of these applications, we were able to set up and get the application running in probably about half a day of actual installation time, and between sort of 2 and 6 hours to put together some jigs and fittings for it. So this slide shows the jigs that we made for the Galvo application. So what we had here was a small copper part about 4 inches long, and so we built several parts for that. We built a gravity feeder so that we could fill a chute essentially with a set of the parts, and the idea being that the robot could just take the next one from the bottom, so it's always picking it up from the same place. And then what it would do is it would lay them out in a small jig we made. So Alex set up one of the Speedy 400 machines to cut a few bits of profile so we could make a simple stand for that. And then what happens is the robot will pick these parts from the gravity feeder, lay them out side by side, and then it will lift that whole jig into the Galvo, which can then do the etching process, and then the robot take them out, turn them around, put it in again and do the other side. And then ultimately it can unload them straight into your final packaging. So if these are going into boxes of sort of 50 parts or 100 parts, it can keep filling those up. The idea being that you have to refill the gravity feeder chute, or you have to move a box every sort of hour or so, but you can leave the robot doing the repetitive part of the task while you're focusing on other things. So in terms of the programming, the first task you have to do is choose the configuration you want. And with our robot, that means figuring out how much reach it's going to need, and you have to consider payload. These parts are all quite light. I think everything we looked at here was less than 5 kilos, so none of that was beyond the limit of the robot. But we did find that this first application didn't need a very long reach, and so we set it up with a medium link tube here and a short one in that section. And that gave the robot plenty of reach to go inside the machine, but it wasn't so long that the elbow was reaching out and taking up more floor space, because most people, they want to make good use of the floor space, and they don't want to have lots of space around the robot or the work area. So having chosen the right robot configuration, we mounted it on a table that was probably about 1.5 feet away from the machine. And then we started to do the programming. So programming is done by dragging the robot to a position. You put it in this free mode where the arm's essentially compliant to move around, and you drag it into a position where you're picking a part up from, store that as a point. You can then drag it to the next position where it's putting a part down or going via, and basically build up a set of points like that. And then at points where it's gripping something or releasing it, we put in a different block to say open or close the gripper. And then once we've built that whole sequence up and we've tuned that, then we can optimize it. We can choose which parts we want to run fast and which parts need to run more slowly. So for example, with this one,
I was going to say, we will also be doing a little live demo of this as well. So we will be going into more depth of that, obviously, so that you can obviously get a better idea and really see that as well. So what we have lined up is with each of these applications, we've just put together a short little video, and hopefully that will allow you to understand the process and also get a bit of visual idea of exactly what we're doing. So I'm just going to get the first video ready to play. Just to note that sometimes the videos can play a little bit loudly, so you may want to turn down the volume a little bit. And we'll start with this first application, and hopefully you'll enjoy some of this video. So I'm just going to play the video in a minute. Okay, so hopefully you saw that. We did have a little bit of information. There may have been some glitches with the video, but if there are anything like that, we will be uploading a full version of these later. So you will be able to obviously view these at a later stage if you want to review them. So one of the things that I really took away from this was just the ease of access in terms of actually setting up the machine, and especially if you saw in a little clip on the video as well, like having the joystick controller, where you've got lots of different ways to maneuver and set up the machine. So the next application we're going to be looking at is again something that I'm sure a lot of you are familiar with, and that is data plate engraving. So in this application, we've moved away from the Galvo. So with the Speed Marker series of machines, that has a dedicated input and output board that works brilliantly with the robot. So by that, I mean we can send signals backwards and forth between them to control the process. Whereas, as Henry's already mentioned, with the Speedy 400, we actually had to use the robot to open and close the door because we don't have an auto feed system. However, with the Speedy 400, we do have a pass-through capability. So you could actually have a conveyor type system running through the machine and then use the robot to load and unload the conveyor belt as well. Obviously, we did all three of these applications in just about a day and a half. So obviously, it's really just to give you an example about how you can combine these technologies themselves. So in terms of the laser side, for this particular application, one of the things that we really tried to use was the laser's ability to create jigs. So having a jig makes it very easy to load and unload multiple objects at a time. And not only is that good if you're just working, obviously, with your normal operators, but also with the robot as well, we could actually lift the jig in and actually load and unload the components. And so I'll just pass back to Henry, who can give us a little bit of information about some of the adaptations they made to the robot for this application.
Yeah, absolutely. I mean, this was a fairly straightforward one because, as Alex said, the machine itself could create the jig. So that was just a bit of acrylic with some pockets cut in it, and then a second sheet of acrylic glued underneath that. So once we had that jig, really all we needed was a vacuum tool. So this is an off-the-shelf vacuum tool. This is made by a company called OnRobot. That's a 2-channel tool, so it can turn on each sucker independently, and that means that it could lift the whole jig into the Speedy 400, but it could also lift out individual data tags and transfer those to packaging at the end. So with this one, we really just needed the tray with the pockets in it and the off-the-shelf tool. There was no other customization at all, and we just set that up on a table and then started the programming. Programming with this one didn't take too long. I think probably the fiddliest bit was getting it to open and close the door gently, but overall I think this took about 3 hours to set up on the day, and making the jig seemed to take only an hour or so with the Speedy 400 itself. So this was quite a nice, simple, straightforward one.
Yeah, and I think another good thing about this particular application is obviously with your system, obviously be able to have the drawings of the components, and we were actually able to share those files. So it meant we could cut the jig from the same file that was used during the simulation of the robot. So it meant actually a lot of the programming for this application was completed by Henry before obviously the machine even reached our location. So what we're going to hopefully do now is we're going to look at doing a little live demo, because I still think it's really good to understand exactly kind of the steps that you would take to set this up. So what we're going to do is I'm just going to remove my screen here, and then we're just going to add your setup here, and hopefully you can give a little bit of a talk through about your setup and how you actually go about programming one of the robots.
Absolutely. Okay, so what you can see here, we're sharing the screen for our user interface. So on the right-hand side, what you get is a 3D visualization of the robot, and that's basically showing you what state it's in, what position it's in right now. And you can use this to do simulations, or you can use it to show you live what's going on. On the left-hand side, you've got a workspace where you build up the steps that make the program. So this isn't writing lines of code. This is basically just dragging symbolic blocks out and putting them in an order. So what we're going to do is just quickly run through a demo of how you do that from scratch. So in this example, we've got the robot here. It's currently disabled. We just click enable in the top corner. This goes green and the robot's live now. And then there's a button here I can press, which makes it free mode. So now it's possible to drag it around. There was just a light touch essentially. As soon as I don't press this button, it's absolutely solid. But this allows me to put it in any position, and this is how I can define where I want it to move to. So Leon's helping me at the moment. He's going to basically pull a block out of one of the toolboxes, which is a waypoint. So here's the first fundamental building block. Each one you can give a name to. By default, they're just given a number. So this is waypoint number 2, and we've added it here. So what I'm going to do is add a second one somewhere else. Put that there, for example. Just click a button to insert another one below it, and then we'll stick a third one above that. So I can do that by moving around here. I can also use these arrows on screen, and this lets us get much finer control. So by pressing those, you can move it very precisely. We can put a step function on, so it will only move it 1 millimeter or 0.5 millimeter at a time. And this allows you to get the really fine alignment if you're doing something delicate. So by combining the free mode where you can drag it around quickly and the fine control of this, you can really quickly put together a whole application. We've also got a controller with it, a pendant, and this is quite useful for just playing and loading programs you've already made before. And this includes a joystick, so that I can basically use those functions here as well. So this is quite handy if you aren't next to the computer and you've got to basically do a fine alignment close up. So having built these 3 steps, we can press play. Now what we normally do is after the first run, we'll run it relatively slowly so that we can check that it's moving in the way we want. And on the 3D graphic there, you can see it moving between those points. So it gives you a marker of where they are and then a dotted line to show you the path it's taking. So to build on top of this, what we can do is we can make it repeat this a number of times, and this is where the power of automation comes in. So if you've defined a step where it's picking up something from there and loading it over here, then all we need to do is tell it to do that 1,000 times. So in the basic toolbox, we've got a repeat function. We drag that out, put it under start, and then we put those 3 points we've defined in that, and then we can press play again, and it will just run around that loop. And once we're confident that it's moving in the way that we intended, then we can turn up the speed and run it faster. And we can do various optimizations where it will blend around points smoothly rather than going there and stopping. We can define some bits as fast and some bits as slow that are more sensitive. And then, of course, the important ability to do other things like open and close the gripper or actuate the vacuum pump if it's picking up something with suction. So a quick example there. You can see the grippers here. You can control with a slider just to choose how it open and closes, and then they can be added in as a block. So in the tool section, we can drop a block under there which says open this gripper, and then we tell it 100% fully open, and then we can put another block in there which we'll set to 0, so it's fully closed. And then if we run that, we can see it following that sequence again, but just with the added gripping.
Yeah, I think that's one of the brilliant things. Obviously I'm very new to this, but the fact that you can obviously do a lot of the kind of the waypoint moves without actually having to code each individual part. You can actually get it to follow the process. So I thought that was really good, and I think that's a great demonstration. Obviously, if you do have more detailed questions about the programming of the system and obviously of the robot, then do ask obviously away in the comments, and then of course you can also contact us, and obviously we can discuss and obviously look at these different applications between us and the solution for you. So what we'll do is we'll go back to our stream, and what we're going to look at now is the application where we had the suction tool. And so the things to look out for this is obviously we're loading in the jig, but we're also taking the parts out of the jig and just giving a very simple boxing demonstration as well. So I'm just going to take the parts and load them into a box as well. So here's the second video, and we'll see you in a minute. Okay, so I'm just going to make a few pointers about obviously that application. And one of the things, obviously, when you're working with this kind of application on something like the Speedy 400, you want to try and make the job as wide as possible. So, of course, all you'd really want to do from obviously the base demonstration we showed you there was obviously you'd have multiple jigs, and then that way you could have the robot load multiple jigs into the bed so you can make full use of the actual working area itself. So we're coming up to the final application, and this is really just to demonstrate that when you're considering looking at obviously implementing the use of something like robotics, it can actually also be worth looking at the process as well. So on the right hand side, you can see that typically you might be using one of our speeding machines with a rotary. This actually will return the object, allowing you to engrave onto it. But in order to really make best use of the robot, what we actually found was that we were using a jig instead, and we were loading multiple bottles into the machine so that we could really get the best throughput possible. And of course, if you have one of our speed marker series, we now actually offer also a focus shift. And what that does is it allows you to automatically compensate all of the artwork and graphics to wrap around a round or a tapered object. So we also have that option as well if you're working with that machine. And in this case, we're also just using the Speedy 400. So I've just asked Henry, what were the kind of changes that we had to make for this application?
Yeah, I mean, this application, we went back to using the tool that we used with the Galvo, the mechanical gripper, because the shape of the bottle was much more conducive to pick with fingers gripping around it, and the ones that we have here. So we used the robotic electric gripper, and for this one, what we did was we drew some profiles of the fingers in a similar way to the way that you would with the Speedy 400, and we just sent them out to a 3D print house. So those fingers cost about 30 quid to have made, and so they're then something that you can reuse again and again whenever you want to handle that product. One of the other differences from working with this machine than the Galvo was because it's a wide, large bed machine, we needed a longer reach. So that was where we replaced this link tube and this link tube with a longer one, and then we extended the arm to have a 1.3 meter reach, which suited that application better. And so that's very useful to have that flexibility.
Yeah, and I think again, I keep going on about it, but that was one of the great things, you know, setting up all of these different applications in a relatively short period of time. And I'm sure, of course, you would spend a lot longer, you know, working with the clients to really make them understand how that they can program it themselves to really optimize it as well. So what we're going to do is we're going to play the final application, and then we're going to finish off by obviously answering any questions you have. So if you do have questions, please do ask away in the comments, and we'll have a look at those. And then also we'll do a little quick chat about the kind of return on investment as well. So here's the final video of the bottle application. So that was our final application, and in terms of the actual processing with the laser, all we were doing was removing that top coated surface to reveal the stainless steel underneath there. Very popular application, obviously personalizing drinksware and obviously adding branding to them as well. So something that's, you know, very on topic at the moment, and a lot of our clients are currently working with. So the final thing we should obviously cover is the return on investment. So what are kind of things that you discuss with your clients for this, Henry?
Yeah, I mean, it's generally based on how are you doing it now and how efficient is that. And if you've got a process where you've got a person manually loading a machine, that's a very low value add that they're doing by just basically unloading boxes and putting them into a machine and closing a lid. And there's almost always something much more useful someone could be doing there, could be getting on with setting up the next job, doing artwork, speaking to customers, or those things that are much harder for a machine to do. So simple return on investment balance is looking at how much is it costing having a person doing that task versus what would it cost to set up the robot and have that investment in that equipment. Typically, when we go back to talking about the difference between our robot and a sort of industrial robot, is industrial robots take a lot of setting up, and you generally have to get very sort of highly trained specialists to program those robots and set them up, and that's a major project that takes weeks or months in most applications. So that's why you normally only saw robotic automation in mass scale production in automotive or those really high volume applications. With a product like this, where you can set it up in half a day realistically, it becomes much more viable to automate batches that are changing every few weeks or few months and cover the cost of that investment over a year or so. But if we look at most of these applications, the balance is still the same. As long as the robot's in use doing something that you would have been otherwise doing manually, then you're comparing the cost of that person doing it manually. And if you're being realistic about that cost, you've obviously got not just the salary, but the NI contributions, the pensions, the holiday, the sick leave, and things like that. And so if you add those up over a whole year and compare them to the cost of buying the robot, buying the tool, a stand or mounting for the robot, and making a set of jigs for the application, then you're looking at somewhere between a sort of 10 to 14 month payback period on that. And particularly with this system, it doesn't really matter if over that year you've got a dozen different applications you do. It doesn't have to be the same year through the same application throughout that whole year. Because of the quick setup, you can move it to something else, and then you spend half a day setting it up, and then that robot can do that task for the next 4 weeks. So it can still be very efficient.
Yeah. And I think, of course, it's very hard to quantify as well. If you have a skilled operator who's currently having to load and unload the machine, there's also going to be added value having them be able to, maybe prepare the next batch of artwork, work on new designs, and so there's always that side of things. Exactly the same on the laser. A lot of our customers have work that you outsource, so it's very easy to cost the cost to the business of outsourcing. But it's also, it's all those extra benefits that you get when you bring equipment in-house, and suddenly, you're able to look at even new projects or new products, and it's really a good thing. So we'll finish off by just having a look at a few questions. So if you do have any questions at all, please do jump in and ask, and we'll have a look at the questions. At the moment, I think we've got a question that was sent in as well before, and I believe it's in relation to the laser side. So it's talking about how will the autofocus work with the robot, and can the machine be moved to a given spot on the material and focus automatically? So assuming from this, you're probably working with one of the flatbed type machines. If you've got the Galvo type machine, then we would simply just input into the work order the work height and the actual focus height for the job. In terms of working with a flatbed machine, what I'd probably recommend is looking at a workflow where we can either use potentially the light beam. So on some of our models, we have a light beam that scans across the top of the workpiece, and you can use that as a focusing point. So we'd maybe have to look at whether we could use that as a method during the process. Or if your material is flat enough and constant enough, then what we can also do is use our software autofocus. So one thing I didn't really mention is when you're looking at working with Speedy 400, you would be looking at automating the workflow using software. Whereas when you're looking at a machine like the Galvo, you can use your inputs and outputs and other ways to communicate with it. So that's generally how we would be working with that. So to see if we've got any more questions, and if you do have any questions, then please do ask away. Hopefully that did answer your question. I guess some of the other things that obviously we could quickly discuss over the next couple of minutes is just also, I know, especially on the laser side, we get asked about maintenance. So I was just wondering, what kind of maintenance is there with the robot?
With the robot, there isn't really any kind of scheduled regular maintenance that you need to do. All the internal parts are sealed. There's no kind of oil or greasing schedule or anything like that. So essentially, the robot can just keep on working for years untended. In terms of sort of support and repair, if there is an issue with a particular part of the robot, because it's modular, we can provide a spare part rather than the whole robot. So if there was a problem in a joint, for example, we can send out a spare joint rather than having to ship back a whole robot and send that back again. So that does make it easier to do maintenance. But in general, they're not. There's no standard required for maintenance.
I guess the final question I would have, if I'm looking at this kind of technology, is what's kind of the process in terms of the, do you offer like a training package with them, or what's the situation there for those looking to purchase?
Yes, we do. Yeah, we offer a training course where we can basically run through the introductory steps, how to use the robot safely, how to program it, how to start looking at more advanced functions. We've got various training videos and things like that available as well, and we've got an online simulator. So one of the nice ways to do is to do the training course, or to even start off with the simulator and get familiar with how to use it, so that when you're using the real robot, it's all more familiar from that point of view.
Well, I was going to say, so look, I think we don't have any other questions. We're coming up on around 35 minutes. So obviously, thank all of you for watching, and this will of course be recorded. So if you've joined this late, or obviously you want to share this maybe with some colleagues, then you will be being sent a link after that. And of course, I'm sure you can find both of our companies obviously on other social media platforms, and we have a huge amount of content in terms of videos on the YouTube channels as well. So it's always good to have a look at that to get an idea of the different applications. So thank you very much. Thank you for taking the time, Henry, and hopefully we'll get some questions and we can help with some customers.
Great, thank you. It's been really good working with you. Really interesting to see what the laser machines can do as well.
Thank you, bye everyone.
Thank you.